going to our this point over here, this point, can you also label this point? In fact, is our Y30 point, right? And this is our, this point over here is also our X30 point, okay? So the Y30 over here, we know that the normal stress is what? What's the value? It's going to be what? The lower value is going to be in tensile by what? 37 point what? 0.682, right? So Y30 over there. So this is your Y30 over here. And that value is 37 point what? 37.682. And then we know the X, okay? X going to X30, that is like 100 over. So that point over there, this is tensile. This is equal to 102.318 megapascal on both terms. When you're designing structures that are what? Carbon fiber. You're not dealing with carbon fiber, it's not important. But I want you to be capable of designing carbon fiber. Okay? Or material that has non-homogeneous property at different directions. Now, hear me out. We know that the shear value is what? 15.973. This is our what? At this point over here, I know this is very messy because my fault, I draw this circle too small. We are aware that at this point over here, this is our what? Our Y30. If you look at the shear, Y30 is going clockwise or anti-clockwise? Clockwise or anti-clockwise? Anti-clockwise. So if Y30 were to go anti-clockwise, the shear has to be going down the slope or going up the slope? Up or down the slope? Down the slope. When you have this arrow down the slope, then the element will rotate what? Anti what? Clockwise. Are we clear? Okay, again, don't write anything. Later on, you can write. Okay, now I'm going to show you X30. If you have a view on X30 over here, the element has to rotate what direction? Clockwise. So this is your Y30, this is your X30 point. Oh, sorry, this is your, Eugene, seriously, what's wrong with you today? So this is your what? This is your, this over here is your X30. So it has to be go in what direction? It has to go in a clockwise direction. So the shear will be going up the slope or down the slope? Down the slope. So this is our shear, and we write our shear over here. The value is equal to 15 point what? 973. Are we clear? Difficult? No. Straightforward. I don't want you to use the formulas. Understand the what? Understand the circle. Okay. Now, Y3D. So what I'm going to do now is to address Y3D. Now, Y3D mole circle. And I'm going to explain this example, Y3D mole circle, because I've been put to become an expert witness before in a case not representing the queen. Okay, I don't represent the queen spot. You know why? Lawyer staff. I will represent the lawyers against the queen spot. You know why? They pay better. The last consulting work I did was $650 an hour. Okay, and it was like $15,000 in 1 week, right? But that's nothing compared to the pay of the lawyer. I found what it's been paid. It's been paid $13,000, no, $1,300 an hour. So I'm a cheap labor over here. Be clear? Right. So why 3D mold circle? Okay. So it's not exactly the same as when I was asked to witness, asked to do expert witness, but it's very similar. Okay. Now I'm going to put the same stress magnitude. I'm not going to introduce anything new, but I'm just going to draw this in what? In 3D. Okay, I'm not going to put any new stresses at all. Okay. So now we have this. So now we do 3D. Okay. So 3D mold circle. This is my X, my Y, and then we rotate about our Z. Okay. So I'm going to draw our 3D mold circle. Right? I'm going to follow the same stress state, 140. So over here is 100. Over here is 40. And over here is our what? 20. Nothing changed. Agree? Right? Nothing changed. This is our point X. This is our point Y. We have a new surface known as our point what? Our point Z. Okay. If you look at the normal stress state, stress X is equal to 100 megapascal. Stress Y is equal to 40 megapascal. Stress Z is equal to 0 megapascal. And we know that this is what? This is a plane stress condition. Yes or no? This is a what? Plane stress what? Condition. Okay. From here, I'm sorry, you have to see me waste your time. I'm going to draw the scale again. Okay, so what we have is we have our normal stress. Okay, and then we have our shearing stress. Okay, again. Come on, someone join me. No one? Yes. Next. Thank you. That's all we do in mechanical engineering. My advice, don't come here. Okay, no, I'm just kidding. Okay, this is a good department. We have some good teachers, we have some horrible ones. It's normal. It takes all sorts to make the world go round, okay? So again, I'll not narrate about this. I'm just going to sketch this out. And I want you all to see something. So this is our 100. This is our 40. And then we have our 20. I'll be quick, okay? I'll be quick. And this is also our 20. And then we determine which is our, this is our Y. Am I right? This is our Y, right? This is our X. And then we drew a circle. Right, we drew our circle. I think it was about 36. Can't remember. Okay, we draw our circle. Anyway. 36, right? I think I need to squeeze this a bit. 36. Okay, we have, it's not really round. Oh, I hate myself. 102 and 37. 102 and 37. 102. I got this illness and my wife told me about it and I agree with her. This ADHD thing or whatever, man. Okay, I don't waste your time. Okay, really don't waste your time. Okay, so we know that this belongs to what? This belongs to an XY plane, right? Come on, write properly. This belongs to your XY plane. And we found out that our tau max is going to be what? This is what? The value is what? Tau max, can't remember now. Tau max is equal to what? 36.05. Right? And then we specify something. We specify a material. Here is your maximum shear if your ambulances is in. Now, question for you and my witness over here now. Did I introduce any new stressors? No. It's exactly the same like what you see in 2D, right? But now, where is point Z? 0. Listen, 0 means where? This is your point what? This is your point Z. When that's the case, the 36.05 is down the what? Is down the toilet bowl. And this is exactly what happened to the case which I was an expert witness to. The engineer ignored the next circle. And the next circle is only possible with a construction of what? 3D mold circle. So now this circle over here belongs to what plane? It belongs to your XZ plane. And when you now have this circle, your tau max becomes what? Come on, Eugene. Your tau max become this value over here. Now this value is equal to, we can calculate that value. That value is equal to what? 102.318 divided by 2. Now the real tau max is equal to 102.318 divided by 2. 51 point what? 16 megapascal. And then we have our third circle. Our third circle is over here. So 3, 1.5, a bit more. This is your third circle. And this circle belongs to your YZ plane. I want to highlight for you. I want you to see the yellow. With just doing by 2D mold circle, you only can get what? 36.05. When we do 3D, it's 51.16 megapascal. Can someone make a conclusion for me, please, regarding the stresses? Okay, I don't waste the time. This is my example. When you have no money, you don't buy anything. Yes? This is my concept. I don't buy anything means, okay, no difference. In stresses, There is a difference. Are we clear? Zero stress means there's a point on what? Whole circle. When that happens, it stretches your what? Circle. Are we clear? That was the problem with the engineer that did the structure analysis, which collapsed. Ignoring what? Okay. Now, not a lot of cases will be like this. Okay. Most of the time, you can get away with what? Remember, I'm not training an engineer. What am I training? A super engineer. Yeah, you want to be an engineer, you go to pilot water. I train to become what? Super engineer. Are we clear? That is why 3D is so what? I used to ignore this. Until I was taught to become an expert witness, I could not understand why the structure failed. And then one fine day, I saw the light. Okay? I was once blind, and now I could what? Are we clear? So those, I mean, question for you, is 3D more certain, more difficult than 2D? What did I promise you? 2D is where you learn more stuff. 3D is just drawing Mickey Mouse. Yes or no? Two more circles. Be clear? Okay, go. I'll see you guys next week. Yeah.